In section 9 of chapter 7, we're going over special factoring techniques. We want to factor the difference of two squares that we had earlier, and then factor perfect square trinomials that we mentioned earlier. And then we're introducing a new topic, the difference and sum of cubes. So again, take some good notes. Let's look at this one. So again, they always start us off easy. So first thing is to see what we can factor out of each term. Well, as we look at this, there's a 3b that we could factor out. And then we're left with a squared minus 1. Now, I don't know if you recall that a squared minus 1 was the difference of perfect squares. So that will factor into its conjugates. A plus 1, a minus 1. So this was a perfect square, this was a perfect square, and the difference factors into its conjugates. Now here, part of it is that you recognize what it is, and again, this is a perfect square. Any power of x to an even number is a perfect square, and 400 is a perfect square. So this will be x to the third, and this is 20 and 20. Now you could put the negative sign here. I tend to put the positive one here and the negative, but they could be reversed because these are the same. Remember, this is defined as the product of the sum and difference of the same terms. And they're putting the plus. I like that. Now, one thing students sometimes get confused of is that here this is the sum of perfect squares, and that is not factorable. Okay? So this is not factorable. So again, this is the sum of perfect squares. This is not factorable. Again, this is the sum of perfect squares. Now you could factor it somewhat by factoring out the common 4 in both, but that's as far as you could go. Now we're getting into the next part of this. So we're looking at those perfect square trinomials that we had mentioned earlier, that you recall if we had a plus x, I guess the way they gave it, squared. We square the first term. That gives us a squared. We multiply these two terms together and then double it. And that gave you, when you took this middle sign, plus 2ax, and then you squared the last term, that this is a perfect square trinomial. So one of the things you might look at when you see a trinomial, is it a perfect square trinomial? And how can you identify it? Well, the first term is a perfect square. The last term is a perfect square. Now, if you take the square root, and let's look at this one here. The square root, and remember, this factors into this, so you might try this if it looks like what we're going to show you. So our middle sign is going to be a negative. And in a sense, there's a 1 there. So z is a perfect square, so you just put a z there. And then you look at the last term, that's a perfect square, so you put a 6 there. That is, you take the square root of that. And then you look at these two terms, multiply them together, a negative 6z, and then double it, negative 12z. This meets the criteria of a perfect square trinomial. So that's what this is. And notice they're showing the doubling for that middle term. So I like the idea that if it looks like a perfect square trinomial, that is, take the square root of this, which is 6, square root of this, which is 1. 1 times 6 is 6, double it, you get your 12. This is the criteria of a perfect square trinomial. All right, let's take a look at this one. Now, what did we say? We said, is the first term a perfect square? Yes. Is the last term a perfect square? Yes. Square root of 4 is 2. Square root of 9 is 3. 3 times 2 is 6. Double it is 12. So this meets the criteria. We're going to use the middle sign right there. This is going to be 2y. This is going to be 3. And then we square this term. Get this, multiply these two together, get 6y, double it, get 12, square this term, we get this. Now, for this one, again, we have to remember, is there a common factor that we can take out? Well, we can take out a 2 for sure. We can take out an x. And that's about it. So we rewrite it. So we get x squared minus 4xy plus 4y squared. Now, this is a perfect square. This is a perfect square. Going to use our middle sign. And we go x and 2y. Square the x, we get x squared. Multiply these two together, we get a negative 2xy, double it, a negative 4xy, yep. And then square this, and we get this. So we got to put our square sign there. There we go. And we factored out the greatest common factor first. And it meets the criteria. Now, this one, it gets a little bit tricky here, because sometimes what they'll do is they won't have this parenthesis here. They'll just have these 4 terms without the parenthesis. And then you have to recognize and put in the parenthesis that this is a perfect square trinomial. So let's do this one, and this is going to factor into x plus 3, the quantity squared. So we have this, and we have this from this. And then we have y squared. So this is now a square, minus this is a square. So we have then, in a sense, the difference of perfect squares. So this could factor into their conjugates, in a sense, which will be x plus 3 plus y here. Remember, let's just do it up here. So we have a plus x going to change that a little bit. I have a squared minus b squared. Okay, so this will factor into a plus b and a minus b, its conjugates. So in a sense, this is our a here that we've written down, a x plus 3, and then plus this term here, which is the y, and then parentheses again, a, not a, x plus 3, which is our a here again, in a sense, and then minus y. So this is our a part, in a sense, a plus b, a minus b. So a plus b, which is what's here, and then a minus b, which is, of course, our y. All right. Let's check it out here. So they are telling us, and again, sometime this parenthesis is not here, so you would have to put it in, is a perfect square. So you would end up with the difference of perfect squares. And then again, this is a, so it would be a plus y, a minus y, its conjugates. And that's what they're showing. Pause, get some good notes. Now, the last part of what we're going to do here is do the sum and difference of cubes. And there is a recipe for this, and I will go over the recipe with you, and this is something you need to practice and hopefully master. So let's look at the general form of it. So we have a cubed plus b cubed. And another variety of cubed. Yeah, let's get the cube there here. Another variety of this is a cubed minus b cubed. Now, there is a recipe for this. And I had to move them over a little bit. I wanted to have a little more room. So what is the recipe? So first, take out any greatest common factor you might have. And these are the basics, so they don't have any other factors here. So the first thing you do is make a parenthesis for 2 terms and a parenthesis for 3 terms. That's why I needed a little more room here. So you want to do this as well. Now, it's the same for the difference. Parenthesis for 2, parenthesis for 3. Now, the next part of the rule, or the recipe, is whatever sign is here, between the cubes, you're going to put that sign there. And for the difference, the same thing. Whatever sign is there, you put here. Now, the next part of this is you want to determine what's your sign in the 3-term parenthesis. Well, if you have a plus there, which is determined from that, you put the opposite sign there. If you have a negative there from this, then you put the opposite sign there. Now, the next part of the recipe is the same for both. We take the cube root of this first term, a to the 3rd, the cube root would be a. The cube root of this would be b. And it's the same down here. So this is an a and a b. Now, the next thing we do is we square this first term. Now, the next thing we do is we multiply these two together, and we get AB, and we put that here. And you might say, shouldn't this be a plus here? Well, this is where we modify just a little bit. The thing is, we determined this sign already by the previous rule. So this sign holds. It is a negative there. It's the opposite of this sign. So that little modification. And then we square this term, which is for our last thing. This will always be positive. And there is the rule for factoring the sum and difference of 2 cubes. So now let's apply it here. We see that they are perfect cubes. So we're parenthesis for 2, parenthesis for 3. And if you're kind of following along, which is what we want you to do, now what sign goes here? Well, whatever sign is there, negative. What sign here? Opposite sign. Cube root of this is x. Cube root of 8 is 2. Now you square the x, multiply these together, disregarding the sign here, we get 2x, and square this, we get 4. Now again, the nice part of this is you can go back and watch it again and develop your mastery. Let's look at some more examples here. And there it is. Now, another thing to note is that this is not a perfect square trinomial, and it cannot be factored. This is as far as you can go. Okay, let's take a look at this. Write it down, and then what will you do? Well, you're going to put a parenthesis for 2, parenthesis for 3. You're going to look at the middle sign, that's plus, So this sign is going to be negative. Now you're going to take the cube root of this. So basically you're dividing this by 2 here. So this will be x squared. And the cube root of 64 is 4. So you may have to work on that a little bit. And then y. Now, why did we get x squared here? Because x squared times x squared times x squared, or x squared cubed. That's where we get the cube root of this is x squared. So now we square this and get x to the 4th. Multiply these two together, you get x squared. Well, I better put the 4 there first. I'll rewrite my negative sign. So negative 4x squared y. Multiplying this times this, but keeping our negative sign from the earlier rule. And then this is plus. 4 times 4 is 16 y squared. Give you a moment. So they're showing it this way. In a way, that's a good way. So you take the cube root for the 2-term parenthesis. Plus sign goes there. And there it is. Plus sign there, opposite sign there. And there it is expanded. Now, as we look at this one, 16 is a perfect square, but not a perfect cube. And this is even, and this is even. So we can actually take a 2 out of here first, and we need to. So this becomes then 8 y to the 12th minus 125. Now, these are perfect cubes. So a parenthesis for 2, a parenthesis for 3. Our sign is negative here. Over here it's going to be positive. Now the cube root of this is cube root of 8 is 2. And divide this by 3. This gives you y to the 4th. Because if we had y to the 4th raised to the 3rd power, that gives you the 12. And this is just, the cube root of 125 is 5. And again, you need to work on some of these, may think of it a little bit. So now we're going to square this. So this is 4 y to the 8th. Multiply these two together. 5 times 2 is 10. Y to the 4th. And then we're going to square 5. That one's the easy part. And there's your answer. So factoring out the 2 first, and now these are perfect cubes, and they're showing that, and then filling in the recipe. And there's your final answer. So a tad challenging. Okay, we went over our 20 minutes a little bit, so here are some others. If you have time and you want to play with them a little, pause, and then these are the answers. Okay.